Okay, let's start. Can you hear me in the Zoom?
You can hide that with a little.
Yes, we can. Right. Okay,
Elio says yes.
that's cool. Okay. Thank you, Ken, for organizing the seminar. Thank you, everybody, for joining here today. I'm gonna talk about how to use Conda to your projects. So this will be a very basic talk about it. And in the end of this presentation, you'll be able to use the basic Conda commands to manage your packages, your softwares, and your environments. Basic Conda is a open source package and environment management system. It runs in every operation system, Windows, Mac, Linux. Using Conda is one of the easiest way to install those bioinformatic packages, Python based softwares, everything. So Conda makes life easier to install them instead of download each software separately and compile them. Conda was first created for Python softwares, but after that, they extended Conda to run other softwares written in other languages like C++, Ruby, Perl, and to use Conda, it's not required to be a super user. So that's a good thing because you can install in every machine. Basically, if you are in a computer lab, let's say these two computers, you have to run a code that you wrote in your own machine. And let's say in this the person one could run the script on this computer and a second person couldn't in that one because there is a software missing in there. If you create a Conda environment and you export those environments to all the machines, you'll be consistent, keeping all the same programs, the same versions along all the machines. And with that, we'll be able to run all your projects, your codes without any issue. When you Google Conda, you find three terms: Conda, Miniconda, and Anaconda. Basically, Conda is the kernel that manages the environments. Miniconda englobes all the functionalities in Conda plus some basic packages, and Anaconda has other packages that's not installed with the basic version of Miniconda. This is how Anaconda looks like. It's for kids. Just point and click what you want to run. Here in this box, you can choose the environment you are working with. But generally for us that works with programming and software development pipelines, we use Miniconda that looks like that. So for unhappy adults to work with that work with a black terminal that looks like more a Microsoft DOS from the 80s. And I'm gonna show you the basic commands to deal with Miniconda, okay? You can install Anaconda in your personal computer and have a look how does it work. When you install Anaconda, it comes with Python version that you selected. It comes with R also, and install together a version of RStudio, PyCharm, Jupyter Lab, Jupyter Notebook, and other softwares to deal with program, like those notebooks to deal with program code. To install Miniconda, you can go to this link and choose the version you want based on the operational system you have and the Python version you want to install. And those are the basic commands to install. I'm gonna share with you later all the presentation. You can copy and paste the commands. So basically, I suggest you keep your folders organized. So usually I create a specific folder called softwares to install Miniconda and other bioinformatic programs. So within this folder, I've downloaded the bash script to install Conda, make it executable with chmod. And this is the command line to install Miniconda. So run the bash script with those flags that are specific flags to run this bash script. Okay, just specify the directory you want to install Miniconda and skip some logs, errors, whatever. At the first time you will run Miniconda, you have to run this command line source Miniconda being activate. To activate Miniconda in the first time, run this conda init bash to create automatically rules to run Conda every time you open the terminal. Okay, and after that you just remove the file that you use to install Miniconda. As in R, Conda has what we call channels. In R, we call repositories. So when people create specific softwares to run with Conda, they stored them on channels. So there are so many channels, like the Anaconda channel, BioConda channel, Conda Forge channel, that stores, for example, BioConda, most of the bioinformatic softwares developed to deal with plethora of projects in genetics and genomics analysis and other areas. So you have to set up first those channels using this the command line. After you initialize your Conda on the first time, every time you wanna run something, you have to type Conda and the other options that comes with Conda. In this case, config add channels, and you add the channels you want. Every time you will install any software later, you don't have to specify the channels that software is stored. So Conda will search automatically in all those channels. Okay. Those are the main channels that I use. So you can find almost everything using those channels. To check the list of channels that is being set up with Conda, you can use Conda config get channels, and to remove some channel, just use the flag remove also. Sometimes you type any name wrong, and it will cause any trouble to looking for packages, and your installation could fail. So if you type something wrong, you can remove that wrong channel with this option.
Can I ask a question?
Yeah, sure.
I don't want to repeat it, but I'll finish just so.
Mm-hmm.
Do you need to have channels, or is it optional?
No, it's not mandatory, but if you don't specify now, you have to specify the channels when you're installing a certain software later. Okay. Sure.
What I get from this is that you want to have separate environments, but they are linked together. So maybe sometimes you just use one environment and you do not want to load the other environment on those packages. Like is it this concept that you're trying to have separate environments and those are connected together? And sometimes you can pull some package from another environment if you want.
When you create an environment with Conda, you create separate environments. They don't talk to each other. There's some options that you can enable that, but the main philosophy to use Conda is to create separate environments, because sometimes when you install a bunch of softwares in the same place, they can conflict each other because of the dependencies that they use. So to solve that, I would suggest creating separate environments for different purposes to avoid these software conflicts.
So over here is like Intel is another environment, right?
Intel is one of the repositories. So there are some software that is stored in this Intel channel.
So all you're doing here is set up one environment.
No, until now we are not dealing with the environment. We are just setting up Conda to install the softwares in specific environments later. Those channels are just the repositories that people stores the softwares that they develop. Okay. Please, if you in the Zoom have any question, let me know or put in the chat.
I'll keep it on the chat.
Okay, thank you, Ken. Once you set up all these Conda channels, again, they are optional. You can set up later when we are installing a certain software. After you did that, it's time to create our environments. So as I said before, the philosophy to work with different environments using Conda is because sometimes when we install some softwares together, they conflict each other. So when you do that and figure it out which software is interfering in the others, the best approach is to create separate environments and install these softwares in their proper environments. For example, I usually do that if I'm working in a bioinformatics project. Let's say it's a project that requires call the variants from the raw sequence files. Okay, I have to install, let's say, 30 softwares to do that. I can create a specific environment that I am calling bioinfo1. Okay, to do that, I'm gonna use Conda create. Flag yes is to avoid the type yes every time Conda asks you, do you want to install it? So if you put yes, it will skip those annoying steps. Name, you can create a name for your environment. And Python, you can choose the Python version to install, that will be installed in this environment, and that will be required to install all the softwares that depends on Python also. This is this alternative command line with short flags, -y and -n for them. And let's say I'm gonna use a second bioinfo environment, can be for another project, for example, imputation analysis, that I'm gonna use different softwares compared to this variant calling project. Or in this case, I'm going to install later a program that is used also for variant calling, but it's not being updated until now. So this specific program that I'm going to install later will depend on Python 2.7. So I'm going to create a bioinformatics 1 environment with Python 3.8 and a second environment called bioinfo 2 with Python 2.7. Okay. And I can do that, for example, if I'm running a project, a deep learning project, I can create a specific environment called DL with the most recent Python version and whatever. Other thing that's cool with Python, you can manage, you can install R with Python, so with Conda, sorry, and you can install different R versions. This is super useful because sometimes people don't update their R packages. So if you are running an older project that requires a set of packages that sometimes not being available for the most recent R version, you can create a specific environment. In this case, I'm calling R 3.6. And you can create another R environment that I'm calling R 4.1 to have these two different R versions. And I'm going to use them later, and I'm going to show you how to activate one or another when you want, okay? So the same flags, minus Y, minus N to assign a name to the environment. Here, minus C is to assign which Conda channel R is stored. So I can specify here or not if I specified before in those Conda config commands. So this is optional. The name of the package in this case is rbase. It will install all the basic R, and you can specify the version. In this case, 3.6.3. In this case, 4.1. And that one is another software called R Essentials. It has all the most used R package, so you can install together with the rbase all the R Essentials package under Python 3.8. So because I choose that because I know this R is compatible with this version of Python.
Piyush asks, do we have to create different environments for different programs?
No, it's not a mandatory, but for example, in this case, when you are dealing with different versions of the same software, it's highly recommended to do that. So in this case of R. But for example, I'm going to show you later that it's possible to install infinite number of softwares in the same environment. Okay. So, and there's this is a simple trick to install different sorry.
We can see that fine, by the way. It's just on your screen.
Okay. Different linear algebra packages in Conda. So if you install MKL Open Blast with R, it speeds up all your calculus process when you are doing a matrix algebra operation. I forgot to put Conda in the beginning of the command line. So Conda install, you select the environment you want and choose the linear algebra package you want, MKL, Open Blast, Bliss. But take care, you have to choose one. For example, if you install MKL, And in your first command line, if you want to use Open Blast, when you install that, it will automatically deactivate MKL. Okay, so just choose one of these command lines. I'm going to fix this slide later.
Is that because there's an R conflict?
Yes.
Okay, so how does Conda know that there's R conflict?
I don't know that. That's a good question.
Nice.
It is. And Conda just recognized that there's a R package in that environment, and it links everything automatically.
So if there was two non-conflicting libraries that you want to install separately, that would be okay?
Yes.
Okay, so it's just because MKL and OpenBlast are conflicting.
A conflict, yes. You can create how many environments you want, okay? Just if you use this command and list, it will print all the environments you've created. In this case, those are my environments in my personal computer, okay? And the asterisks indicates which Conda environment you are using right now. Okay. In previous step, I created those environments based on Python 3.8 and Python 2.7. Now you can install the softwares when you specify the environment. So Conda install, select environment here. The Conda channel is optional because we specified before. And this is the name of the software that I want to install in Bioinformatics 1 environment, so GATK. You can install as many softwares as you can. So, but you have to be sure that they won't conflict each other. When you are installing, Conda will detect the conflicts and will show you a log, a very ugly log to you. So don't worry, you will know when they will conflict or not. So, and you can be more specific and choose the version of the software you wanna install, okay? And this is how to install another software. So just to show you that I'm installing Platypus variant in a different environment because it runs with Python 2.7 and not with Python 3.8. And how we know when a software runs in a Python version or another Python version? The easiest way is to Google it. So put the software name plus Conda, and the first search will redirect you to the repository, the Bioconda, the repository that that has that software. So here you have the command line to install it. And if you add recipe on Google, you'll be redirected to this Bioconda recipe page. And here you have the Python versions that accept Platypus variant. So this is how you know the proper Python version you want to select during the environment creation. And those are all the Platypus versions available to be installed. The nicest thing to use Conda to install these softwares, Conda will choose the best version for you that does not cause conflict with the other softwares that is installed in the environment. So Conda manages everything automatically for you. Another way to search the program versions is to use Conda search and the software name. In this case, the RBase. It will show you a list of are available for you, and the weird name of those packages and the channel that contains our base. Now, how to select an environment to work with? Using Conda activate. So Conda activate bioinfo, one in this case, and you're gonna show you that the terminal command line will gonna change from base Conda to bioinfo1 Conda. So every time here you have the current environment name. To deactivate the environment, just type Conda deactivate without the environment name. Okay. So when you activate a specific environment, Linux won't recognize the other softwares installed in the other environments. So Conda separate them automatically. However, if you create, for example, I want to use environment that I installed all my bioinformatics softwares, and also I'm going to use R together. I want to use all of them at the same time. You can activate bioinfo1 environment, and after that, use the flag stack and the R4.1 environment. Although the command line shows you only the R4.1 environment here, both are activated to you. So you can use all the software installed in both environments. Be careful not to have software that conflict each other across environments.
Using the Conda activate or Conda deactivate commands, do they take a long time to activate? Like, or is it?
No, it's almost instantly.
Wow.
Yeah. So, and I forgot to add a slide, and I would really highly recommend you to use Conda, create those Conda environments, install softwares on HPC, because instead of using all those annoying module loads or module search for a certain program, you can create your own environment and just activate and use all the softwares at once. Sure.
So very often I run into problems in Python where some package requires some other package. That package has a different version, but I think there are some tools in Python where you can solve, where the system can solve the configs itself. So that's when we run into an issue of software version config, does Conda has any option to like resolve it itself?
Yes, when you are installing a certain package there, Conda searches for all the compatibilities with the packages and software that has been installed in that environment, and Conda tries to solve those conflicts. For example, if the newest version of a software conflicts with the rest, Conda will try former versions of that. And in the worst case, if it's impossible to solve, Conda will show you a log and you have to create a different environment for that.
I think that highly depends on you specifying the version. So if you don't specify the version, it will assume that has flexibility.
That's correct, yes. If you go strict to a version, Conda will try only that one. But if you don't specify, Conda will find the best version for you. And okay, if you don't want to use anymore a specific environment, you can remove, Conda remove the name of the environment and flag all to remove everything from that specific environment and remove the environment also. To update a package, just use Conda update, the environment name and the program you wanna to be updated. To remove a package, Conda remove also, but just specify the environment name and the software name. Or if you are, in this case, if you are in the, for example, in the base environment instead of the bioinfo one. However, if you are in that environment, you don't need to specify the environment name. Just remove the software. Another cool thing about Conda, you can share your environment across computers. So it will make your projects more consistent across machines. So if you install 30 softwares in your machine and you wanna work in another server, another machine, you can export your environment and restore it later from that YML file. So Conda and export specify the environment name and output in a YML file. Okay. Using this approach, Conda will export all the softwares packages in bioinfo1 environment, specify all the versions that was installed in that environment. However, if you want to share the Conda environment across platforms, you have to add this from history flag. It will tell you Conda not to include the specific versions and specific dependencies for those programs. Conda will install then automatically when you migrate from a platform to another. So this is a smart way to share your environment across operational systems.
Powerful.
It is. And after that, when you create, let's say, a backup of your Conda environment using this approach or that one, to restore that from this YML file, just use Conda env create -f and the file name, and it will create exactly copy of the former environment. Well, those work with Conda is very simple. Okay, Conda is very powerful and can solve lots of problems for you about those software compatibilities, environmental management. So if you have to deal with so many softwares at once, I highly recommend you use Conda to administrate your softwares and environments. Okay. I put my GitHub for this presentation and explain a little bit more the command lines. I put some basic good tutorials on that, and feel free to send me an email if you have any questions. So I have my MSU and my personal email for you here, and let me know if you have any questions.
Thank you very much, Rodrigo.
Thank you.
There's only 2 of us in the room, so
Uh-huh.
it's a little lackluster, but imagine everybody else also applauded. Okay, do we have any questions? I just wanted to say that I didn't realize how useful this is for collaboration. Being able to create that almost Docker container-like environment and sharing it across.
Yes.
If you're working on a paper together with, say, 5 people, different universities, you can easily just send out the latest YML and everybody immediately has everything they need.
Yes, really they will be able to run the exactly same scripts on the exactly same programs.
That's brilliant.
It is. And an advantage that I see compared to Docker, you have to have the super user definitions to install it. For example, we can't use Docker on our HPC. However, once Conda doesn't require it, so it can be installed in any machine.
The gauntlet has been thrown down.
Sure.
I love using Jupyter Lab, and whenever I do something like, I always select the Python environment. And I've seen that there's a Conda environment as well. So I use Python environment, and then if there's something missing during the writing process, I just install it in the terminal Python 3, install this. But I haven't used Conda. But can I use Conda and a specific environment that I have created, maybe Ali or some other? So
I think so. I think you can.
Okay. That would be super useful.
I'm not sure how to do that, but I'm pretty sure you can.
If not, there must be a way of easily listing all the software and all the packages you have installed in Python to then easily maneuver them into a new Conda environment, right?
For example, there's a hidden slide here. For example, where is that? That one. For example, to create I just keep that for my records. When I'm dealing with a deep learning project, for example, those are all the Python packages that I install within this DL environment. So yes, you can create a list of packages that you require with Python and install them with Conda. It's super useful. For example, when I try to install TensorFlow and Keras without Conda, they conflict each other. When I migrate to this approach, I didn't have any problems anymore.
I was using TensorFlow and Keras like 2 weeks ago, and there were lots of
Yes. So
does the recipes, does that solve a similar problem that you see in Docker as well, where you can share containers with other people? So you have a recipe that basically has an environment. Okay, what you can do. So my question, I guess, is there a portal of a set of environments that have a set of software within each of them for specific purposes publicly?
What do you mean? I didn't get.
Share environments. Is there a portal for sharing environments?
I never seen that, but maybe. I don't think so. Like Docker, you can share environments in an integrated system. I'm not sure if there's any for Conda. I think it's more for personal projects.
Okay, so I think it'd be cool if.
Yes, it would.
Say, for example, you do a paper
and
you have used 27 different pieces of software. It'd be very useful if you had a portal that you could point to and say, there's the YML document that I use to use all the right software for this project. And there could also be hundreds or thousands of other projects in the same portal.
What you can do is share your IML file with the paper. It will be super useful also, because it's not a big file.
Provide requirements file, and then they tell you that you create your own environment and use that.
Yes.
Use these versions of these files. Don't take them from the requirements.
Yes, this is true.
What I usually do to put available on my GitHub is to create 2 files to create that one with the specific versions that I've developed something, and the from history file. So generally I put available both. So if someone is using Windows instead of Linux, they can have at least the list of softwares that I used, and they can access, manually open the YML file and check which version of software did he use when he developed something. So.
Okay, I don't think we have any more questions. So thank you so much, Rodrigo. That was a fantastic presentation.
Thank you.
I feel like I have another tool in my belt. So thank you so much.
Thank you for inviting me.
I haven't tried this, but I was thinking of maybe I create a Docker container